Hello Year 10s and welcome back to mathematics. In this video we're continuing with our topic of linear relationships and we're going to be looking at the next section which covers an idea called the gradient. So by the end of today's lesson what we want to be able to do is we want to explain what the gradient is, identify the parts of the gradient formula, and to be able to calculate the gradient of a linear relationship. So that's what we want to be able to do by the end of this lesson. Now a quick recap of last lesson. Last lesson we talked about line segments, and in particular we were talking about the midpoint and the length of a line segment. So the way that what we talked about was that if we want to find the midpoint, what we want to do is we want to find the point which is directly in the middle of my line segment, so it's that each side is equal. And the way that we did this was we took the two x coordinates and y coordinates. So here A would have x coordinates and y would have x coordinates, and we took the x coordinates and we averaged the x coordinates. So averaged the x coordinates, and then we also averaged the y coordinates. And so here, when we were trying to find the coordinates of that midpoint, we took the average of the x coordinates and we averaged the y coordinates. So we added them together and then we divided them by 2. Now, the other thing that we did was we looked at the length. Now, the length was how long it is to get from A to B. And in order to do that, what we did was we noticed that we had to use Pythagoras' theorem. And so what we did was we had to figure out how long it was horizontally between the 2 points and how long it was vertically between the 2 points as well. And so we had to find those two before we could actually figure out our use Pythagoras' theorem. So if we wanted to find the length, what we did was we took the square root of, and the notation that I used last lesson was delta x for the length, horizontal length, and delta y for our vertical length, and we squared both of these and added them together. So that's how we found the midpoint and the length from last lesson. Today we're going to be talking about the concept called the gradient. So here is a quick definition of the gradient. Now, the definition here. The gradient of a line measures how steep or sloped the line is. So different lines will have different steepnesses and different slopes. And what we want to do is mathematically, in a mathematic way, describe how steep or how sloped it is. So the way that we calculate this is we use this formula, which is the gradient. So here, the gradient notation that we use for the gradient in mathematics, we often represent it with the letter m. And the way that we do this is we write this as rise over run. So once again, if you have a look at this diagram that we have under here, if you remember what we said, not if you remember, the rise is just how far up or down we go. Now, if it goes down, it means it's negative. If it goes up, it means positive. So here, from A to B, it goes upwards like this. So this looks fairly similar to our Pythagoras' theorem diagram, actually. So this here is my rise. And my run underneath is just how far it is to get from A to B. So this is my run. This is my horizontal distance. Now, when we're doing this, we want to read from left to right. So the first coordinate that we want to do is our A, and then the next coordinate that we want to do is our B. Now, when we do this on a Cartesian plane, all our points usually have coordinates connected to it. So what we can do is we can actually write this in a mathematical way. And the way that we do this is if we read from left to right, we're going to just call our A coordinate our first coordinate. So here, this is my first coordinate. I'll just call it A again. But I'm just going to give it these coordinates. I'm going to give it the coordinate x1 because it's my x coordinate of my first coordinate, and y1 for the y coordinate of my first coordinate. And similarly, on the other end, at B, because that is my second coordinate, because I'm reading it from left to right, B is going to have the x coordinate of x2, and it's going to have a y coordinate of y2. And so here, if I want to find the rise over run, the way we do this is, if you remember from last lesson, if we wanted to find the rise or the how high it is, or how many units it has to go up and how many units it has to go across, the operation that we need to do is subtraction. And so the way that we do this is we go y2 minus y1 for the rise. So for my rise, I'm going to have y2 minus y1. And similarly, for my run, I'm going to have x2 minus x1. So here, x2 minus x1. And so that's how we find the gradient. We need to use this formula, rise over run. And we need to use, if we have coordinates, we use this part here, y2 minus y1 over x2 minus x1. And so let's have a go at a couple of examples. We're first going to start off with a couple of examples where we actually just find the gradient from a diagram where we don't need any coordinates. And so here's example 1. We've got two examples here. First one, find the gradient of the following line segments where each box equals 1 unit. Okay, so for these examples, we're just going to use that equation. The gradient is equal to rise over run. So how many units it has to go up or down by? The rise is going up and down, and run is going across. And so here, let's have a look at the first one, A. Here, my formula is m is equal to rise over run. And so I'm just going to find how many units we need to go up and how many units we need to go across. So if you have a look here, we can just count this out. The rise is just going to be, well, if I go from A to B, I need to go up 1, 2, 3, 4, 5. And so here, my rise is going to be 5. And so I can put that in my formula, 5 for my rise. And I need to divide that by my run. Now my run is just how many units I need to go across. So here, 1, 2, 3, 4. So here my run is going to be 4. And so I can write my answer as 5 over 4. So that's how we go about these questions here. Let's have a look at another example. This one looks a little bit different. Now for B, we've got these points C and D. Now once again, I'm going to try and find my rise over run. And I realize I should probably use my colors and make it look a little bit nicer. So B. So what I said was the rise over the run. Now for B, the rise is how many units you can either go up or down by. Now, if you go down, however, so notice here, if I'm reading from left to right, to get from C to D, we actually need to go down. So when I go down, instead of counting the units as positive units, I'm going to count them as negative units. Whenever I go downwards, I'm going in the negative direction. So here, let me just count up the units. So here I go down by 1 unit, 2 unit, 3 unit. So here for my rise, we've gone down 3 units, and so it's going to be a -3 because we are going downwards. Because the rise is going downwards, instead of going up, we are going down. It's going to be a negative rise, or a negative value. So we're just going to have right here -3. And once again, our run is the distance we're going across by, our x coordinates. So here, my run, I'm just going to count up the units for my run. So here, I'm going to go 1, 2, 3, 4, 5, 6, 7. So here my run is equal to 7. So my final answer here is -3 over 7. So that's how we actually use this formula, rise over run. We want to count up how many units we're going up or down by. And so here we want to make sure that, first of all, we want to make sure that we're reading from left to right. So we start off our left coordinate and then we move towards our right. And then from there we go, okay, cool. How many units do I need to go up by or down by? If we're going down, it's a negative value. And if we're going up, it is a positive value. And then we count up our run. So how many units do I have to go to get from my left coordinate to my right coordinate? And I read it across. So that's how we use this formula for gradient, to calculate the gradient. Let's have a look at another example, this time where we're actually looking at it from a graph. So here, we're going to have a look at these examples. So this one here, example 2, finding gradient from the graph. Find the gradient of the following lines. Now this first one here, we don't have units, we don't have a grid to actually help us to help us count up the rise and the run, but we have coordinates, and the coordinates are actually quite helpful for me because the coordinates tell me where it is, the y value, so how far it is up, and also my x coordinates, so how far is it left and right. Now, when we're trying to find the gradient, we need 2 points. In this diagram, we only get 1 point given to me, which is this point here at 220. But if you have a look, there's actually no other given point here. There's actually one that's hidden at the origin, O. And so here, when I'm trying to find the rise over run, we're just going to try and look at how many units do I have to get from my origin to my point over here. So I'm just going to write the formula, m is equal to rise over run. So once again, just like we did before, we're going to start with from our left and we go to our right. Now, I start from origin O. Now, origin has a coordinate of 0, 0. And we're going to look at the rise. Now, the rise is the y coordinate. How many units do we need to go up by? Now, if you have a look at my second coordinate, what is the y coordinate of 220? The y coordinate of 220 just happens to be this 20 at the back here. So what this tells me is to get from 0 to 20, now I need to go up 20 units. So here my rise is going to be 20 units. So here, rise is 20 units. Over. Now that I've done my rise, I'm going to do the exact same thing with my run. To get from 0 to 2, how many units do I need? So I'm looking at 0 and 2 because those are my x coordinates. Those are my horizontal units. And so here, to get from 0 to 2, that's only 2 units. And so here, that is 2 units there. Okay, and so we've figured out that our gradient is just found by 20 over 2. Now, when you see a fraction, there's a hidden there's the operation that it's telling you to do is actually division. So 20 over 2 is just the same as 20 divided by 2, which if I do 20 divided by 2, that gives me a value of 10. So for this question, I'm going to have a final answer of 10. Okay, that's my first example. Let's have a look at another one. Here, we're going to apply the exact same steps we did before. When we're looking at the rise, it's our y coordinates. And when we're looking at the run, it's our x coordinates. And once again here, we have one point at 15, -5. And we have a second point at the origin. And so here we're just counting up how many units to get from the origin at 0, 0 to my point here at 5, -15. So let's do this. M is equal to rise over run. So let's start off with our rise. Now our rise is our y coordinates. So here we're starting at a y coordinate of 0 and then we're going to -5. Now if you have a look, that is a rise going downwards. So that value is just going to be, my rise is just going to be, I realize I should have done this in pink. We go from 0 to -5. That rise is going downwards, which means it's a negative value. It's going to be a value of -5. So here, my rise is going to be -5. So that's my y coordinates, which give me the rise. And the same thing, what I need to do is then I need to look at the x coordinates for my run. Now the x coordinates, horizontal distance, I'm going from 0 all the way to 15. So that gives me 15 units here for my run. And so I'm just going to write here 15. Now, when you see a fraction, you are doing division. And what we can do with fractions as well is we can also simplify. We're looking for a number that both goes into 5 and -5 and 15. 5 goes into both of them, so I can divide top and bottom by 5, and so that leaves me with 1 over 3. So this final answer becomes -1 over 3, like so. Okay, so that's my first two examples here. When we're trying to find the rise over run with our coordinates, if we're starting from the origin, we're just looking at what the y coordinate is for my rise, and then for my run, I'm just looking at the x coordinates. So rise is going to be with my y coordinates, run is going to be with my x coordinates. Okay, there's two more in this set, and then we're going to have a look at actually another set after this. But these are two special lines. These two lines are vertical and horizontal lines. Now, vertical and horizontal lines have special gradients. Now, let's start with C. Now, C, we have a horizontal line. The thing with horizontal lines is that the gradient is going to be 0. It has no steepness at all. So the way that we show that is we say that the gradient is 0. It's neither going up or down, it's just staying flat, which means it has a gradient of 0. So if you ever see a line that is horizontal, that means it has a gradient of 0. Okay, part D. This is a vertical line. Now, if you see a vertical line, that means that it has an undefined gradient. What this means is that this value cannot actually be found. The reason being is that it's not going horizontally at all. It's not going horizontally at all. We do not go left and right with a vertical line. And so because of that, that would result in my rise being 0. And in mathematics, we can't actually divide by 0. That's just one of the big problems that we have. Not problem, but just one of the things that happens in math. You can't divide by 0. Okay, so if you see a horizontal line, that means it has a gradient of 0. And if you see a vertical line, that means it has a gradient of undefined gradient. Okay, Those are my 4 examples here. What we're going to do in the final part of this video is actually go through a few examples where we're finding the gradient between 2 coordinates, not just the origin and the point, but 2 separate coordinates. So let's have a look at the steps that we need to do for this one. So if we're calculating the gradient for coordinates, there's a few steps I want you to do. The reason being is we're going to be using this formula, y is equal to y2 minus y1 over x2 minus x1. And I'm not sure about you, but when I look at this, and the first time I looked at this in high school, I was like, this is a confusing formula. So what we want to do is actually make this as simple as possible and go through these steps so that you don't get lost and actually are able to calculate the gradient accurately. So what we're going to do, the steps we're going to do is we're first going to, step 1, label the first coordinate. So we're going to read our 2 coordinates from left to right, and we're just going to write down our first coordinate and we're going to label it. We're going to label the x coordinate x1, and we're going to label the y coordinate y1. And then we're going to repeat that same process with our second coordinate, but instead of writing x1 and y1, we're going to write x2 and y2. Then once we've done that, what we're going to do is we're going to substitute the values into the formula. So we're going to look at this formula, and then we're just going to substitute those values into those spots. And then once we've done that, we're going to simplify our answer. So let's have a go at a couple of examples where we need to do this. So here we're going to use this formula, y is equal to y2, the gradient is equal to y2 minus y1 over x2 minus x1 to find the gradient of the line segment between the following pairs. So let's have a look at this first example. This first example, I have 2 points, 1, 2, and 3, 8. So first step I'm going to do, the first step was to label your first coordinate. Now the first coordinate, we're going to start from our left, and we're going to then we're going to move to our right. So our first coordinate is just going to be 1, 2. 1, 2, because that's the coordinate on the left here. So what I'm going to do with 1, 2 is I'm going to label the 2 coordinates. So here, this 1 is my x1. Oh, I'll write this with a little bit more space. This is x1, and 2 is my y1. So here I'm just going to label the coordinates. So I'm going to, because it's my first one, I'm going to put those ones at the bottom to tell me it's the x coordinate of my first point and is the y coordinate of my first point. Okay, so that's the first part. The second thing we're going to do is then we're going to do the same thing, but this time with my second coordinate. Now the second coordinate is the one on the right. So here the second coordinate is going to be 3, 8. So I'm going to go 3, 8. I'm going to do the exact same thing, but this time instead of writing x1, y1, we're going to do x2, y2. So here, 3 is the x coordinate, so that's going to be x2. And 8 is my y coordinate, so it's going to be y2. So here we have our 2 points labeled. Once we've done that, we're just going to use the formula here. M is equal to y2 minus y1 over x2 minus x1. So let's go about using that. So I'm just going to write down that formula. y2 minus y1 over x2 minus x1. All I'm going to do is I'm going to replace my letters, my pronumerals in my formula with the values in my points up above that we've just written. So let's start off with the top. It's y2 minus y1. So where's y2? Well, y2 is over here, which is the 8. So I'm going to write here 8. I'm going to minus y1, which is just a y coordinate on my first point, which is over here, which is 2. So I'm going to do x minus 2 over. And then I'm going to repeat the same thing, but now with my x coordinate. So my x2 value, so x2 is this guy over here. So x2 is here, and so it's going to have a value of 3. So I'm going to write 3 minus x1, which is just my value over here, which is 1. And so I'm going to do 3 minus 1. Okay, now that we've done that, we're just going to fix up the top and the bottom. We're just going to do those calculations. So 8 minus 2 at the top was 6. And at the bottom, 3 minus 1, that's 2. And so here our answer is 6 over 2. Now 6 over 2, the final bit that we need to do is we need to simplify. Whenever you see a fraction, there's an operation of division. So we're actually going to divide the 2. I'm going to go 6 divided by 2, which is just 3. So my gradient on my first line here is 3. And that's how we go about doing that. Okay, let's have a go at the second one. Now the second one here, notice it's going in the opposite direction. It's going downwards this time. So that means that my answer should be negative. but we're going to go through the same steps again. So I'm going to read from left to right, and my first coordinate is the one on the left. So my first coordinate is just going to be the one on the left, which happens to be -3, 4. So I'm going to write here -3, 4. Okay, I'm going to label my two coordinates here. So here, my -3 is going to be x1, and my 4 is going to be y1. Okay, and once I've done that, I'm going to do the same thing, but with my second coordinate. My second coordinate is my other one, which is on the right, which is 5, -1. So I'm going to go 5, -1. And so once again, I'm labeling x2, y2. Okay, so I've written down my coordinates and I've labeled down each one as x1, y1, and x2 and y2. Okay, so after I've done that, what I'm going to do is I'm just going to put it into the formula. The formula here is, let me try that again and let me get my pen to work. There we go. Okay, my formula is y2 minus y1 over x2 minus x1. And so all I need to do is just put in those numbers into the correct spot. So from my labeling, y2 is just -1 minus y1, which is 4, over x2, which is 5, minus x1, which is -3. So once I've done that, I just need to start to simplify the stuff. So here in the top, I've got -1 minus 4. -1 minus 4 will give me -5, over. At the bottom, I've got 5 minus -3. So that minus and minus makes a plus. So this becomes 5 plus 3, which is 8. And here, now that I've got 5 over 8, I'm trying to see if I can simplify it. I can't. And so my final answer is just -5 over 8. And so that's how we can calculate the gradient if we get given two coordinates. So that's it for this lesson. Let's just do a quick recap. The gradient is a measure of how steep a line is. And the way that we calculate our gradient is we use the formula rise over run. What we need to do is we need to figure out how many units we go up and down by. That's my rise. And then we need to figure out how many units we go across by, which is my run. And then we divide those two values together. We went through a few examples of how to do this on the diagram, and we also went through how to do this using coordinates. And with the coordinates one, where it's a little bit trickier, we just want to make sure that we label our coordinates first so that we can substitute the correct values into our formula. So hopefully that helps. If there's any questions, as always, you can send me an email or send me a message, and I'm more than happy to try and answer your questions. But until next lesson, Year 10s, I hope you're staying safe wherever you are, and I'll see you then. Bye.